last time I remember doing these. Do you remember how to do these?
Yeah.
Okay, what do I do? What's my first step?
Well, tangent of negative or inverse tangent is like it's an angle.
Okay, so we'll call that a theta. Now what?
So you know that tangent of theta equals 2.
Okay. Missing a vital step here.
Draw the triangle.
Yes, always. Draw the triangle, and has to be a right triangle, and you have to label theta. Now you can dimension that triangle. What are the dimensions of that triangle?
Opposite is 2. Adjacent is 1.
Hypotenuse?
And then hypotenuse is square root of 3.
It's the sum of these squares.
Square root of 5. Sorry.
So what's the cosine of theta?
1 over square root of 5.
Perfect. Let's do one more before we go on. These are huge. To be able to do these is big. So how do I do B?
I had this test on Thursday.
Okay. Should we go on right away? You're good with this?
Yeah.
Okay. Let's go to the next one. You did good on that first one. Don't think... Is this the material you want to go over, or do you have new material?
So our final's just over everything.
Okay, well, this probably as good as any then. Yes or no?
Yeah, I just don't know. I wish he made like a final exam review instead of a just rely on the others.
The problems I'm looking at here are quintessential trig problems. You're going to have these on any trig test in the world. So can't hurt to do these. Let's do 3. First step. And this truly is the quintessential trig problem. If you were going to ask a trig student only one problem, this might be it. First step. What do you do whenever I say first step?
Draw a triangle.
Okay. Do that. Don't make me ask that second thing. And what else? Not only do I draw a triangle, what else do I have to do?
Label it.
Label the angle we're talking about. What's the angle we're talking about?
A.
Alpha. Okay. Now, this information allows you to dimension that triangle, 2 sides of it. Dimension it for me.
Oh, okay. So opposite is 7. 3 is adjacent.
What's the hypotenuse?
Square root of 40.
It's the square root of the sum of the sides squared.
Square root of 58.
Okay, it's not the difference. When you are solving for the hypotenuse, it's always the sum. When you're solving for one of the short sides, it's always the difference, starting with the hypotenuse squared. Okay, and that's fine. So now we turn our attention, not yet. Tell me what the cosine of A is in this triangle.
3 over square root of 58.
And now tell me what its plus or minus sign is, based on the fact that it is in quadrant 2.
Negative.
There's your answer. And that is an exact answer. And that's probably an answer your teacher would accept, despite the fact that root 58 is in the denominator. In other words, we have an irrational denominator. And that doesn't even simplify. No, that's 29 times 2. Okay, now, to do the second part, we need the identity. Give me any identity you want. Any of the three are going to work because we're looking at the triangle. So we can calculate all 6 trig functions if we wanted to. So just give me one of the 3 identities. It's the easiest one.
Tangent.
Now for cosine of the double angle, there's 3 different identities. Got to memorize these. Here's the 3. Cosine squared of alpha minus sine squared of alpha. Well, we could use that, but it's got 2 different trig functions. Let's pick the one that only has 1 trig function. That one. And here's the other one. All 3 of these identities have subtraction going on. The bottom 2 both have the trig function multiplied by 2. I'm just trying to give you ways to memorize all 3 of these. Which is the easiest one to use?
Two cosine.
Yeah, because we've already solved for that. So, plug in. What's cosine squared of alpha equal to?
So it'd just be 3 over square root of 58 times 2.
You got to square it. You got to square it. First of all, you got to put it in parentheses. And then you have to square top and bottom. So what's the top square?
9.
The bottom square?
58.
What's the sign going to be?
Well, it's squared, so it'd be positive, right?
Correct. That's the answer, minus 1. Okay. So what is that equal to? That's equal to 18/58 minus 1. Well, that would be minus 58/58. So that's minus 40/58. And that is equal to minus 20/29. I know that's as far as I can reduce it because 29 is a prime number. But the answer here, give an exact answer, minus 20/29. Notice that we're taking the cosine of an angle and we're getting a ratio. Never forget that with trig. You take trig functions of angles to get ratios. You take inverse trig functions of ratios to get angles. Simplify. Now that usually means this is going to come down to a single trig function or a single number. We're not going to have anything complicated. What am I going to do? It's the first step.
Well, you could substitute it in for the difference formula thing.
No. The problem is, no. When you see a problem that says simplify the trig expression, start thinking convert everything to sines and cosines. So do that. If I convert that's already cosine. What's tangent?
Cosine over, or sine over cosine.
What's cotangent?
Cosine over sine.
Now we got everything in sines and cosines. What's that equal to? Distribute it.
It'd be cosine over, or cosine times sine over cosine squared.
Hold on. When you distribute it, this cosine of theta cancels with that cosine of theta. So the first term is sine theta. What's the second term?
Cosine squared over sine.
Okay. Now, how do we add two fractions?
Find a like denominator.
What's the common denominator going to be?
Sine squared.
No, just sine. There's only one denominator.
Oh yeah, that's all right. And then sine squared is the first term.
Okay, correct.
And cosine squared.
Still cosine squared. So now what are we looking at? We're looking at sine squared plus cosine squared all over sine, right? In other words, you don't change the common denominator. It stays the same, and you operate on the numerators.
So it'd be 1 over sine.
And what's that equal to?
Cosecant.
There you go. There's your answer. Feel like we did this problem. You remember?
Yeah.
Did we do it?
I think we did.
Yeah, I think we did too. Let me, I kind of remember doing the tangent problem also. Let's move on. Yeah, I guess I'm going to have to start making notes because I'm not remembering. Do not remember that tangent cubed equals tangent x. Do not remember that. So I think we left off somewhere on problem 5. I kind of remember doing A. I do not remember. Let's do B just as refresh. Even if we did it. The reason I remember doing B is because it involved recognizing what that is. It might have even
I forgot.
C. First of all, you need to know your identities, backwards, forwards, and like the back of your hand, Zach. You cannot depend on a cheat sheet. You cannot depend on a piece of paper that has all the identities on it. You're just not going to be able to do this if you do that. You're looking at 100 identities on that piece of paper. Finding this one is not easy. So the only way to really recognize this is to memorize it. That is the sine of 2 theta. It's the double angle formula, or it's rather the double angle identity. Okay? So now I get sine of 2 theta equals square root of 3 over 2. Now what? You solve this.
Would you divide by 2? Or?
No. Remember, when you're trying to solve for angles, you have to use inverse trig formulas. We're trying to solve for an angle. Actually, we're trying to solve for 2 times an angle. So how do I solve for 2 theta?
Inverse sine of 2 theta?
Well, no, it's the inverse sine of the other side. Remember, you take trig functions of angles, you take inverse trig functions of ratios. You don't take inverse trig functions of angles, ever. You take inverse trig functions of ratios. You take trig functions of angles. So, where is 2 theta equal to square root of 3 over 2? What are the angles for 2 theta? And it's important that you understand that we're solving for 2 theta. We're not solving for theta yet. We're solving for 2 theta. Where's the sine equal to square root of 3 over 2? What am I going to do? I'm going to draw the 2 triangles that I've drawn 50 times.
It'd just be 1.
Dimension the one on the left.
Square root of 3 is the longer bottom side there. 2 is the hypotenuse. So 1 is the other
1
side.
is always opposite the smallest angle. Okay, so this is 1, 1, square root of 2. These 2 triangles, if you can memorize what you're looking at right there, that will take you so far it's unbelievable. Because now you know which angle is 2 theta. Where is the sine of which of these angles is equal to square root of 3 over 2?
Sine of 30?
No, sine of 30 is 1 over 2.
Sine of 60, okay.
Okay, so the answer to 2 theta is 60. Remember, we're looking for an angle. That's the first quadrant answer. They want all the answers in this domain. So where else is the sine equal to square root of 3 over 2? What other quadrant?
It'd be the second quadrant, right?
Okay. What's the same angle in the second quadrant that's the same as 60 degrees?
Uh, 120.
Okay. The only thing I didn't like was the inflection in your voice, meaning you weren't quite sure. Okay. Now we get to a difficult concept. They told us to look where theta was from 0 to 2 pi. So where's 2 theta?
From 0 to 4 pi.
So you have to find all the answers from 0 to 4 pi for 2 theta. We're solving for 2 theta. We're not solving for theta yet, which means we have to get all of the answers out to 4 pi. What's the next one?
It'd be 420.
And the next one?
480.
Okay. That's out to 2 or to 4 pi. Now you can solve for theta. Give me the 4 answers that theta is.
Be what, 30 degrees, 60 degrees, 20 or not 20, 210 and 240.
Notice that all 4 of those are in that domain, 0 to 2 pi. But the only way you get these 2 last answers is if you increase your domain for 2 theta out to 4 pi. Most people, if I was grading the tests on this exam, every wrong answer is going to have only those 2 answers, which means only those 2 answers. People are going to miss those 2 right there, because they don't extend the domain out to 4 pi. They leave it at 2 pi, which means they come up with those 2 answers. Those are the only 2 answers they think they have. They divide them by half to get 30 and 60, but they omit the other 2 answers. So very important to expand that domain to whatever it needs to be. All right, hold on a second. I think that's the last one we did before. I don't think we've done this one. What do you see when you see that? Anything? What if I wrote this? What if I told you 3x squared equals 2x plus 1? What do you see down there?
Quadratic.
Okay. Well, guys, that's the same thing. If I were to let x equal sine of t, which you can certainly do, this is a valid math process, is substitution, then that becomes that. They are the same thing as long as x equals sine of t. So let's deal with that for the moment. We can do it more directly, but I think it's significant to use u substitution to actually think about this. How do I solve this? This is now an algebra problem, not a trig problem for the moment.
You move the 3x squared over.
That's going to give it a negative coefficient.
You move the 2x plus 1 over.
Yeah, because that leaves the coefficient of the x squared as a positive 3, and it's really hard to factor these if you have a negative coefficient in front of the x squared. So factor that.
Be 3x minus.
Hold on, do it. Don't do it that way. Split up the 3x squared first.
3x and then the other side's x.
Now determine both signs. There's only one thing they could be. You cannot produce a negative 1 constant unless your signs are the opposite of one another.
So plus 1 minus
If they were
1.
both negative or both positive, that'd be a plus 1. So they have to be different. Either have to be plus minus or In this case, minus plus. Well, there's not many choices about the factors of 1, so let's just start plugging it in. 1 and 1. Does that produce the proper middle term?
Yeah. If the first one is minus, or I mean the first one, yeah.
You're right. If I do the double smiley face, I get plus 1x and minus 3x. Add them together, you get minus 2x. That's our middle term. So we factored it correctly. Now we got to go back and resubstitute. In other words, we did the whole problem as an algebra problem. Now let's go back and make it a trig problem. So what has to be true? Give me some trig functions I can write. Well, here, first of all, let's make this a little clearer. Those are our two solutions. 3x plus 1 times x minus 1. Let's substitute. Let's go back and do this substitution first. Let's go back and resubstitute the trig function. So what does that give me? Substitute sine t for x.
3 sine plus 1.
3 sine t plus 1 times
Sine minus 1. Or sine t minus 1.
sine t minus 1. All that's equal to 0. Now we have a trig problem. How do you solve this? You still use the algebra. In other words, the basic algebraic principle is probably the most important algebraic principle there is, which is if you have two things multiplied together that equal 0, one of them has to be 0. So how do you solve it?
Set one side, or
Set both of them to 0. That's how you solve it. If I tell you AB equals 0, then the solution is A equals 0 and B equals 0. So what's the next thing I want to write?
3 sine t plus 1 equals 0 and sine t minus 1 equals 0.
Yeah. And solve that one. I'm going to need to, hold on.
Sine t equals,
Yeah, I need to do some,
1/3.
yeah, I need to do some erasing here. Let me erase all this stuff over here. I can start writing on the left. Unfortunately, when I run out of paper, I can't scroll with this technique. So here's what I have. I'm going to start this. 3 sine t plus 1 equals 0. Solve that.
Negative 1/3.
Solve that. What angle? And we're looking at angles that are between 0 and 2 pi. So what's t going to be equal to? Remember, we're solving for the angles here. If sine t equals minus 1/3, how do you get t?
Inverse sine.
Always. Of?
Of negative 1/3.
Look that up on your calculator. That's not a common one. In other words, that's not a 30, 60, 45 or anything like that.
19.47.
What's the sign in front of it say?
Negative.
How come you didn't read that?
I don't know.
Dude, your calculator's not wrong. It's negative. That's a fourth quadrant angle. What was the number?
Negative 19.47.
Degrees. What quadrant is that in?
First quadrant?
Nope.
No?
Fourth.
Oh, negative, yeah.
Negative angles are like that. That's a negative theta angle. Positive angles, you go counterclockwise. Negative angles, you go clockwise. So that's fourth quadrant, and that's correct. We know that sine is negative in fourth quadrant. But there's another quadrant where it's also negative. And your calculator can't give you this answer.
Third quadrant?
Okay. What's the equivalent angle to that in the third quadrant?
It's like 199.
189. Oh, you know, you're right. Absolutely. Sorry. It is 199.47. So there's your two answers. Now, notice that one of our answers is a negative angle and the other one's a positive angle. That's perfectly acceptable. I could also have said that that is 340.53. That's the same angle as minus 19.47. So I could give that, and it would be correct. I could give that, and it would be correct. But it's okay to give a negative angle. In fact, every time you do the inverse sine of a negative number, you're going to get a negative angle. You're always getting the fourth quadrant angle, and it's always going to be given to you as a negative angle, never a positive angle out of your calculator. So know what to do with these negative angles.
Okay.
And that was all there was, because we were looking for all angles in the first unit circle. Well, there's the fourth quadrant angle. There's the third quadrant angle. Only two quadrants where sine is negative. What's the most immediate problem you see when you look at this problem? When you're solving trig equation, what's the biggest problem? Doesn't exist here, doesn't exist there, doesn't exist there. But it definitely exists right there. What's the difference between those four?
The sign to greater than or equal to, or the equal to.
No, the difference is this got two trig functions in it. This got one trig function, one trig function, one trig function. This one's got two different kinds. And it's extremely difficult to solve trig equations when you have two different kinds of trig functions. So our goal, can we turn this into one trig function? What's the identity for sine of 2 theta? Again, back to identities. And again, if all you had is a cheat sheet, you wouldn't necessarily know to use the sine double angle. But if that's all you had, go ahead and look it up. Tell me what sine of 2 theta is.
I don't remember it off the top of my head, but I think it's like sine A, right, plus cosine A
No, it's 2 sine
times.
theta cosine theta. In other words, we had an earlier problem where this is what they gave you. And you had to figure out that that was sine of 2 theta. Okay? So notice now that if I write the equation like that, now I can solve it even though I have 2 different trig functions. I still have a sine and a cosine, but always be thinking factoring. Always be factoring. ABF. Always be factoring. What can you factor out of this expression? Trig ultimately comes down to algebra. You got to know the underlying algebra.
Factor out a cosine.
Okay. What's left?
2 sine theta plus 1.
Now, solve it algebraically. What has to be true? Got 2 quantities multiplied together that are equal to 0. It's the whole reason we factored it, was so that we could get 2 quantities multiplied together equal to 0, because we know how to solve that. How do I solve that?
Set 1 equal to 0.
Okay, cosine of theta equals 0. Where does that occur? In the unit circle.
It'd be 0, -1, or I mean 0, 1.
No, actually just 0. If I draw the cosine curve, there's only one place right there where it's equal to 1. Or excuse me, where, my apologies. My apologies a lot. Cosine of theta is equal to 0 at pi over 2. And where else based on my chart?
Every time it goes back.
Well, there's pi over 2. What's that one?
2 pi.
3 pi over 2. In other words, you know the range is from 0 to 2 pi. So these key points, and I mean key, are 0, cosine is equal to 1, pi over 2, pi, 3 pi over 2, and 2 pi. So the key points is cosine is equal to 1 at 0, it's equal to 0 at pi over 2, it's equal to -1 at pi, and at 3 pi over 2 it's back to 0, and then at 2 pi it's back to 1. So there are 2 places on that curve where it's equal to 0, and that's pi over 2 and 3 pi over 2. So that solves that part. Now let's solve this part. What's this mean? What's
Sine of theta is -1/2.
Where does that occur? Unit circle. Hold on.
45 degrees.
No. If there's one angle you want to memorize, it's 30 degrees. The sine of 30 degrees is equal to +1/2.
So -30 degrees.
Okay, that's one answer. That's only one quadrant, though. We always know there's two quadrants. In other words, we're going from 0 to 2 pi. So we have to, that's the unit circle, okay? So we need both answers. You've given me the fourth
210
quadrant
degrees.
answer. What's the third, which other quadrant is sign negative?
Third.
What's the angle that's equivalent to minus 30 degrees?
210.
Correct. There's your two answers. So actually there are our four answers. In other words, if you plug any of these four answers, and I apologize for putting one in radians and the other in degrees, I guess since they're defining the domain in terms of radians, I should leave everything in radians. So minus 30 degrees is minus pi over 6. 210 degrees is 2 pi over 3. No, excuse me, 4 pi over 3. Hold on, let me think for a second. That's pi plus pi over 6. That's 4 pi over 6. That's 2 pi over 3. So if I'm putting everything in terms of radians, it's minus pi over 6. Actually, that's not in our domain, is it?
No.
What's the correct angle that is the same as minus pi over 6, only it's in our domain?
Two pi over 6?
You add 2 pi to this. If you add 2 pi to that, what do you get? In other words, right now we're in,
5 pi over 6.
what do you get?
5 pi over 6.
You get 11 pi over 6. That is the fourth quadrant angle that is in that domain. It's the same angle as minus pi over 6, but it's in the unit circle. It's not negative territory. So our answers are 11 pi over 6. And notice your calculator did not give you that. You have to come up with that on your own. In other words, your calculator may have given you pi over 6 or minus 30 degrees, but you have to convert that to get it inside this domain from 0 to 2 pi. And minus pi over 6, add 2 pi to it to make it positive, you get 11 pi over 6. Also have 2 pi over 3. I also have pi over 2. And I have 3 pi over 2. There's your four answers to this problem. Every one of them is inside that domain from 0 to 2 pi. If I would have put an answer minus pi over 6, that's not in that domain. Notice, that domain is only positive angles, not negative angles. So, and the problem is that your calculator, when you give it when you take the inverse sign of something and you give it a negative argument, it always gives you a negative angle. It gives you the fourth quadrant answer, but it gives it to you as a negative angle, and you actually have to convert that to a positive angle. What's minus 60 degrees equal to as a positive angle?
Uh, 300 degrees.
Okay, good. You know how to convert negative angles to positive angles. This trig is not that tough, but what you have to know is your identities, and you have to know to solve it algebraically. And you have to know your four quadrants. and your unit circle. So you actually have to know quite a bit. So what's the first step for solving that? If I told you x squared is equal to 1/2, what would you do?
You bring over 1/2 and make it equal to 0.
You take the square root of both sides.
Oh, okay.
When you have an algebraic equation where the variable you're trying to solve for is being squared, it's always correct to take the square root of both sides, and your answer always starts with the words plus or minus. So that's the answer. And instead of x squared, we have a trig function squared. Doesn't change anything. So what is the cosine of theta equal to? Still going to use algebra to solve it.
Square root of 1/2.
What do you always start your answer with? What word?
Plus or minus.
That matters. That's 2 extra solutions. In other words, if you omit the plus or minus, you're going to lose 2 solutions. Because this basically, we're going to have an answer that's all 4 quadrants. Okay? Because of the plus or minus. In other words, if I had plus only, I would be in first and fourth quadrant. If I had minus only, I would be in second and third quadrant. But I have all 4 quadrants, and plus or minus, each one gives you 2 answers. So we're looking for the angle. You can get this out of your calculator. And that's what you should do. Use either one. Just do the inverse cosine of square root of 1/2.
No, I did it wrong.
Do it again.
60.
No. Oh, excuse me. Yes. No.
Square root of 1/2.
Yeah, square root of 1/2, not 1/2.
45.
Okay. Now, that's our basic angle. We want all 4 quadrants. What is the same angle as that? What's the second one? We know that we have 2 quadrants where it's plus, and we have 2 quadrants where it's minus. Well, that's all 4 quadrants. So all we got to do is take this basic angle, 45 degrees, and apply it to the second, third, and fourth quadrant. And then all 4 of them will be in that domain. What's the second quadrant angle that's the equivalent of 45? That's what you have to look at. Right there.
So 130. Wait, no. Yeah, 135.
Correct. How about the third quadrant?
Good. 225.
And the fourth quadrant.
Uh, 315. Geez, that took me way too long.
It's all right. It's all right. You got them. Now, if you go into your calculator and you say, what's the cosine of 45? It's going to give you square root of 1/2. It's going to give you plus. If you say, what's the cosine of 135? it's going to give you minus square root of 1/2. Cosine of 225 is going to be minus square root of 1/2. And the cosine of 315 is going to be plus square root of 1/2. So these four answers satisfy what theta is. You could put any of these four angles in to this equation, and your calculator is going to give you 1/2. If you put cosine squared of 45 or cosine squared of 135, your answer will be a positive 1/2 in all cases. All we're doing is going in reverse. What do you see when you look at this problem F? And I want you to see this. This is important. When I say, what do you see? What do you see? You see
Quadratic.
Yeah. You see trig functions, but they're a quadratic in disguise. If I had to let x equal something, what would it be?
Cosine t.
Okay, now what we're looking at is 2x squared plus x minus 1 equals 0, right? Now, you don't necessarily have to do this step. Substitute a polynomial for the trig function, but until you get used to it, it helps, because I know you can solve that. This happens to be the same as 2 cosine squared of t plus cosine of t equals 1. So I haven't changed anything. We've just used a substitution to make it a little bit more comprehensible. Now factor it. These are always factoring problems. What was that? That was plus x. Yeah. This is why factoring is such an important skill, because you have to do it all the way through trig. Guess what? All the way through calculus. You never get to a point. It's not like geometric proofs. You have to know those for like 2 months. Never again. But factoring is something you have to know through 3 or 4 different disciplines of math. So let's factor this as a polynomial. It's a little easier just because we're used to factoring polynomials.
So it'd be 2x and then 2 on the other, and x on the other side.
Okay.
And then it'd be, first one would be minus 1, and last one would be plus 1.
Okay.
Okay.
It's fine with me if you skip steps as long as you get it right. And you got this one right. So I'm not going to argue about skipping steps. In other words, when I factor, my second step is determine both signs. My third step is determine what numbers go there. And I do it one step at a time. I just find that helps a lot. So now let's resubstitute, put this back in the form of a trig function. What is it? In other words, we got to solve the trig problem. We don't have to solve this polynomial. We got to turn it back into a trig problem. We just used the polynomial to make it easier. So turn it back into a trig expression.
So it'd be 2 cosine t minus 1, and then cosine t plus 1.
Good. Now, solve that.
So they're both equal to 0.
Okay. So in the first case, cosine t is going to be what?
1/2.
Now give me all the angles where that's true in the unit circle. And you can give them as degrees if you like. I mean, I don't know whether your teacher is really strict on this. If they give you the domain in radians, they want you to stay in radians. I don't know. Let's do one step at a time. Give me the answer in degrees if it's easier.
60.
That's one of them. There's always two in the unit circle. Where else is cosine positive?
Fourth quadrant.
What angle is the fourth quadrant the same as 60?
300 degrees.
Okay, that takes care of that one. Now let's do this one. Cosine of t plus 1 equals 0. Solve that for t.
Be let's see.
Welcome home.
My roommate's here. Yeah. So be -1. Pi over 2.
Just pi. Look at my curve over here. Remember, these key points are always, that's pi over 2, that's pi, that's 3 pi over 2, that's 0, that's 2 pi. So when you're looking for the place where it's -1, there's only one spot in the unit circle, and that's pi, which is 300 or 180 degrees. So if we're putting our answers in degrees, our answers are 60, 180, and 300.
Well, I was watching the boys.
Okay? Let me just say one thing about G and I'll let you go. We won't solve it. The first step.
Dividing both sides by tan x.
That's a problem. If I divide both sides of an equation by something that can be 0, and 0 is a solution, I lose that solution. If I say x
So you
cubed
subtract it.
equals x, and I divide both sides by x, I lose the solution that x is equal to 0, because I end up with x squared equal to 1. Well, I don't find x equals 0 anywhere in there. So the fact that I divided both sides by x and x equals 0 happened to be a solution, I lost it. And the same thing happens here. So yes, you divide, you don't divide both sides. You never want to divide by something that might be 0. So you subtract tan x from both sides.
And then you factor out a tangent.
You factor out a tan x. And you're left with tan squared of x minus 1. And then you solve both of these, just like we've solved everything else. Set tan x equal to 0, find its solution. Set tan squared x minus 1 equal to 0, find its solution. But an important distinction, because for years I used to want to divide both sides by tan x there. I finally realized you can't do that. Just remember, you cannot divide by 0, ever. And you can't divide by a variable that could be 0. If you know a variable can't be 0, well, then you can divide by it. But in our case, tan x could be 0. So we can't divide by tan x. We want to subtract it from both sides and then factor and then solve it normally, the algebraic way. All right, Zach, when's your final?
Next Tuesday.
Okay, so are we going to have some more sessions before then or not?
Yeah, I don't know. Do I have any scheduled still, or?
I don't think so. Let me look. I don't see. No, you don't have any after today.
Okay, then I can schedule some.
You can go in and schedule some, or I'm happy to do it for you now if you like.
Okay, when are you available?
There's my availability right there. I got tomorrow night, there's an hour-and-a-half window here. Thursday, there's here. Friday, Saturday, and Sunday, there's lots of availability. If you can do early, that works pretty good for me.
Okay, let's see. Tomorrow, you don't have an early tomorrow though, right?
Unfortunately, I don't. I have a meeting tomorrow morning.
Thursday, let's do
Thursday, I
that.
got a lot of earlies.
What is that? That's 1 to 2 on Thursday?
I could even do 1:30 to 2:30. Does that work better?
Yeah, we can do that.
Let me put you in there. Talk to you at 1:30 on Thursday.
Okay.
All right, Zach. Talk to you then.
Thank you.